All right, guys, this is Friday, April 24th, and we're doing section 5.5. So again, if you would follow along in the book and grab your calculators, we'll definitely need that for some of these problems. Okay, so what we've got for a lot of these, a combination of algebra and ultimately putting things into the calculator. So for this first one, I'm supposed to solve for x, and then I want to check my answer. If I could get it down to one logarithm, I could rewrite it using an exponential. So I'm going to use some of those properties that we just learned yesterday. So these are both log base 10. So I can write log, and then because I'm adding, that's equivalent to x times x plus 3 equals 1. Okay? So now I'm going to rewrite using exponential. So if this is base 10, 10 to the first power equals x times x plus 3. Okay, and now we're just dealing with algebra that we've done before. So 10 equals x squared plus 3x. I have a quadratic, I'm going to get 0 on one side. Okay, I believe I can factor this. So what numbers multiply to 10 and subtract to 3? Of course, 5 and 2. Okay, I need a positive 3, so we'll go positive 5, negative 2. So at least initially, I think x could be negative 5 or 2. Okay, now it's really important, they say check your answer, that's very important for these logarithmic ones. If you recall back when we were graphing logarithms, the domain was that we had to be greater than 0. So this negative 5, I can't take the log of negative 5. So I need to eliminate that as one of my solutions. If I put a 2 in, 2 times 6 is 12. I'm just gonna test it out. So I'm gonna go 2 store x. Now I'm going to go log of x plus log of x plus 3. I press enter and I get 1, so I know that one works. We do have to eliminate the negative 5. Okay? This is just saying if we have log with the same base on both sides of the equal sign, just like with exponents, we can just ignore the logarithms then and set these expressions m and n equal to each other. So I'm close to that here, but I've got some condensing to do. So on the left side, I've got log of x plus 2. And on the right side, these are both log base 10. Addition becomes multiplication when I condense. So this is the same as log of 7x. Now that I have the log with the same base on both sides of the equal sign, I can ignore the logarithms and say x plus 2 equals 7x. Subtract x. 2 equals 6x, divide by 6, and x equals 1/3. Let me write that neater for you guys. Okay, so double check that we got that, yep. Okay, this one over here, similar. Both are natural logs on the left side. Subtraction becomes division with our quotient rule. Both sides of the equal sign have natural log on them now, so I can say 87 over x equals 29. Multiply both sides by x, 87 equals 29x. And so x is going to be 87 over 29, okay? So if you can get that, using the properties we learned about yesterday, if you can condense that, then it's pretty straightforward. And of course, 87 over 29 is just 3. Okay. Okay, so similar. I'm going to condense the left side, so I'm going to go the log. I've got a subtraction, so this is going to turn to division. I've got a common log on both sides, so I can ignore that. So I'm going to go x plus 12 over x equals x plus 9. To get rid of that denominator, multiply both sides by x. And now I can see I've got a quadratic, so I'm going to get 0 on one side. Subtracting that x gives me plus 8x minus 12. Okay? And then I'm going to work up here. Are there any numbers that multiply to 12 and subtract to 8? I don't think there are, you guys. So I don't think we're going to be able to factor that, which means quadratic formula, okay? So x is going to be the opposite of b, plus or minus square root of b squared, which is 64, minus 4 times a, which is 1, times c, which is negative 12. All over 2a, 2 times 1 is just 2. Okay, so we're gonna try to simplify this a little bit. So 64, you got minus a negative there, so 64 plus 48, what is that, guys, 112? Okay. Um, 16 goes into 112, so we can say this is, the square root of 16 is 4, and 16 times 7 is 112. Divided 2 by everything. Okay, so at least initially that's what I think my answer is going to be. Negative 4 plus or minus 2 squared roots of 7. But again, if I choose the negative 4 minus 2 squared roots of 7, that's a negative answer. And I try to put that into here and it doesn't work. So I have to eliminate that one. Okay? The negative 4 plus 2 squared roots of 7, if I check that out, works. So the only one I'm going to choose here is the negative 4 plus 2 squared roots of 7. The other one, again, we didn't use because it was negative and I can't take the log of a negative. Solve the exponential equation, answer both an exact and approximate. So now I've got exponents and I'm going to need logarithms to get rid of them. So I'm going to try to isolate the exponent. So 4 to the 3x, I'm going to add 1 to both sides, equals 9. And then I can undo this using logarithms, guys. And I'm always going to use the natural log just because it's easier for me. That exponent comes out in front. So I go, when I take the ln of this side, I get 3x ln 4 equals ln 9. Okay? And I'm trying to solve for x. So if I want to get x by itself, that's going to be ln of 9 over 3 ln of 4. Okay? So on the top I've got ln 9. On the bottom I've got 3 ln 4. I get about, so this is my exact answer here. And approximately to 4 decimal places, they say I get 0.5283. Okay. Again, I think you should get in the practice of putting that back into your calculator just to make sure that that works. Okay. But you'll have to trust me on this one, that this one does work. Okay. All right, same thing. I've got both sides of the equal sign that are exponents and the bases are not the same. So I'm going to take the natural log of both sides and the exponents come out in front. So I've got x plus 1 ln of 5 equals 2x ln of 6. Okay, now I've got x's on both sides, so I'm going to have to get all the x's to one side. I'm going to distribute here first. So this is x ln 5 plus ln 5 equals 2x ln 6. So I'm going to take both expressions that have an x and move them to the same side. So I'm going to leave this ln 5 on this side. And I'm going to subtract this x ln 5. And then on the right side, I can factor out that x. So if I factor an x out, I've got 2 ln 6 minus ln 5. And to get x, excuse me, to get x by itself now, I can divide both sides by that expression. So this side will become ln 5 over 2 ln 6 minus ln 5, and that's going to be x. So that would be your exact version of that. Okay, let's see what we get when we work it out here. So on the top I've got ln 5. On the bottom I have 2 ln 6 minus ln 5. Okay, I get 0.8153. Okay, let's just double check that. Yeah, book gets the same thing. This is a little different than what the book has. They rewrite it a little bit differently. I like this version a little bit better, okay? But if you have what the book has, it's equivalent, so you're okay. All right, find all solutions. All right, so if you follow the book in this one, it says, let's go ahead and solve this graphically. So my suggestion to you guys, go into your y equals. Okay. And put in the left side, you're going to put e to the cubed root, and cubed root's in math there, you guys, of x minus 8. Okay? And then in y2, you're going to put the square root of x plus 9. Okay? Remember, we're taking square roots, so you know your window. If you want to just look at your normal window at first and try to graph this, just negative 10 to 10. Let's see what we get here. Okay? I see two graphs, but it looks like they cross farther off to the right. So I'm going to go back into my window, and I'm going to change my window to go from 0 to 20. Okay? And I'm going to regraph for a second. Okay, so give that a minute to load up. Okay, so it looks like they cross in there. I'm going to go to second calculate, which is above trace. I'm going to choose intersect. First curve, second curve, guess. My calculator is telling me about 11.43 for the x coordinate. And so sometimes taking the log of both sides isn't going to be super helpful, so that's always a solution, you guys. All right? Okay, example 7. A small business makes a new discovery and begins an aggressive advertising campaign, confident they can capture 66% of the market in a short period of time. They anticipate their market share will be modeled by this function. This is a logistic function, which you don't necessarily have to know, but that's what it is. Okay, where m of t represents the percentage after t days. Use this function to answer the following. So for part A, what was the company's initial market value at t equals 0? They're just asking you to put a 0 in, you guys. So go back to your main screen, and you are going to put 66 over 1 plus 10 e to the 0, basically, because you're raising that to the 0. So I get 6. Okay? So on the calculator for this one, m of 0 equals 6. So what does that mean? So after 0 days at the beginning, the percentage of the market share that you hold is 6%. Okay? What about after 30 days? Okay, so I'm going to rewrite that same problem, but instead of e to the 0, I'm going to go e to the negative 0.05 times 30, because we're doing it for 30 days. Okay? Well, this one, m of 30, is 20.4. So after 30 days, we'll hold 20.4% of the market. How long will it take the company to reach 60% market share? Okay, so I gave a blank sheet of paper here. We'll kind of go back and forth. Okay, so I'm going to go back for a second to remind you. We're trying to get 60% market share. We're going to put that in place of the m of t, and then we're going to rewrite what we see on the right side. So we'll double check. So we're going to go 60 equals 66 over 1 plus 10 e to the negative 0.05 t. So I want to know how many days that takes. Well, now I've got some algebra to do, honestly. 30 days I was at 24%, so I can expect it to be longer than 30 days, okay? If you're following along in the book on this one, it says it's going to take about 92 days. That's where we should get, but let's do the math. Let's get rid of the denominator. So I'm going to just multiply both sides by that bottom number. So I'm gonna multiply by 60. 60 times 1 is 60, and 60 times 10 e to the whatever is 600 e to the negative 0.05 t. And that's gonna then equal 66. I'm gonna try to get this e all by itself. So I'm gonna subtract 60. I'm gonna divide by 600. So 6 divided by 600, that's not a very big number. 0.011 100th. E to the negative 0.05 t equals 0.01. Now to get rid of an e, I can take the natural log of both sides. So this side I'm going to eliminate the e, and I'm going to get the ln of 0.01. Okay? And then I have to divide by this negative 0.05. So the ln of 0.01 over negative 0.05. We said, what did we say? 92. Let's see if that's what we get here. So on the top, ln of 0.01. On the bottom, negative 0.05. Sure enough, I get about 92 days for that to occur. Okay? So there's a little bit of algebra involved in some of these, but they give you the formula. That's not something you're going to need to know. They're going to give that to you. Okay. Suppose a group of climbers had just scaled Mount Rainier, the highest mountain of the Cascade Range in western Washington state. The mountain is about 4,395 meters high, and the temperature at the summit is negative 22.5 degrees Celsius. What is the atmospheric pressure at this altitude, given that the pressure at sea level is 76 centimeters of mercury? Okay, so they give you the formula, H equals, etc. Okay, and so what is the atmospheric pressure? Well, the H, you guys, they give me 4,395 equals 30 T. T is temperature, so that's going to be negative 22.5 plus 8,000, and then times the ln of P sub 0, that's at sea level, over P, like so. Okay? So what I've got to do here is some algebra or some graphing. That's kind of up to you how you want to tackle that one. Okay? It looks here like you're getting about 41.7. We can certainly do this algebra. So inside the parentheses here, 30 times negative 22.5 plus 8,000 is 7,325. So I've got 4,395 equals 7,325 ln of 76 over p. Okay, and so I got to get that ln by itself. So I got to take that 4,395 and I got to divide it by 7,325. I get 0.6. Now I can rewrite it as an exponential. Okay, so this is ln or base e. So e to the 0.6 equals 76 over p. Okay, which means p is 76 over e to the 0.6. Let's see what we get there. Oops, did it wrong. 76 divided by e to the 0.6. Yep, and so I'm getting about 41.7 centimeters of mercury. Okay, you could have graphed that though, you guys. You could have put 4395 in Y1 and then the right side in Y2, set your window appropriately, and found out where they crossed. So we're just solving problems here. All right, so there's your problem. Again, we're going to do every other odd, you guys. Good luck.